Hi, EDU 790 folks. This is Jennifer Steele, and today I'm going to be presenting how to do topic 2 data task. And so we're going to be looking at how to clean data, how to merge data together so that we take two data sets and can tell a richer story by pulling in information from two distinct but complementary sets of data. So today the data that we're going to be working with are the data sets are the one that we used for topic 1, which is the data set of COVID deaths in the United States for each state and for each racial ethnic group during the year 2020. That's data from the Centers for Disease Control, CDC COVID deaths 2020.dta. But we're going to be combining that with information about the lockdowns, the COVID lockdowns in each state, the start times and end times and durations of those lockdowns, so that we can do some analytic work, and we'll work on that during topic 2 and during topic 3. So to find these data, the data are housed in the Canvas course, and so you will download the data first from Files, and the Files menu is right over here on the left-hand side of the Canvas course. It's on the left navigation menu. And so I'm just going to click and open that link in a new tab. And the data are always housed in the data folder. So I'm going to click, and by the way, if you need help downloading data and saving it to AU OneDrive, then there is a video in the media gallery on the course website. So right here in media gallery, there's a video that explains how to do that if you're having difficulty doing that. But right now, so you probably already have CDC COVID deaths 2020 in your AU OneDrive, but you may not yet have lockdown 2020, which is not a Stata spreadsheet. It's actually an Excel file, XLSX. It's an Excel file. So we're going to download that, assuming that you already have COVID deaths 2020. If you don't, you would download both of them. And so to download a file, you click these 3 dots adjacent to the file, and we're going to click download for lockdown 2020 XLSX. And then we're going to navigate to OneDriveAmerican.edu. Then we're going to go to documents, assuming that that's where you typically save your files. And then for me, within documents, I have a special folder called EDU 790 on my OneDrive account. That's where I download my data. So I'm going to save it to that folder, lockdown2020.xlsx. Now, in fact, I already have it in that folder, so I'm not going to actually click save. But if I didn't have it there, I would click save, and then it would be there. As before, you can also just download it somewhere else on your computer and then drag it to your OneDrive by opening OneDrive in a browser. So that would be portal.office.com, portal, P-O-R-T-A-L, .office.com, to open up OneDrive in a browser. And then you can take your spreadsheet from some other place on your computer and drag it to your OneDrive account. So that's another way to get the data into OneDrive. And there's one other way, which is by doing it all through the virtual desktop. So again, there's a video on the course website that explains, under Media Gallery, that explains how to do that. Okay, so let's say we've got our 2 data sets in our OneDrive account. So that is CDC COVID deaths and lockdown. Okay, and they need to be in our AU OneDrive folder because in a moment we're going to open Stata and we need to be able to find them there. So I've provided a text file. If you want to use some scratch paper that has the questions written down, you can, this is a link to that text file, but if you want to just work directly in the Canvas quiz interface, then that is fine too. And you can always save your data because Canvas will remember what you've typed in and it will not lose it even if you don't click submit. So that's a nice feature. Okay, so the first instruction is to go into, once you've got your data downloaded, is go into the virtual desktop and open Stata. And the virtual desktop, as you probably remember, is something that you should probably have bookmarked by now. I have bookmarked it right here. as remote desktop web client. And that's how I get to the remote desktop. I'm going to close that because I actually already have it open right here. So I'm going to clear my data so that I can start from scratch. And I'm going to right click in my results window and clear results. So everything is clean. I have no data in memory. Everything is clear, except that I do have some commands over here that remembers. To get rid of that, I would just close Stata and open it again. Okay, so now let me go back to the quiz and walk you through the tasks that we're going to do. The first thing we're going to do is set our working directory, and we're going to start doing that in every assignment. We're going to always start by setting our working directory, which is the folder that Stata knows to go to save data and to open data, so that you don't have to type a long file path every time. And that's going to make it a lot easier for us to follow the steps together. Okay, so to set your working directory, we're going to go File, in Stata, the File menu, scroll down to Change Working Directory. We're going to go to OneDrive-American.edu, Documents, EDU 790, or whatever you use for your 790 folder. Whatever you use to save files for this course, that is your working directory, and you'll need to remember what it is. So that's the one I'm choosing. OneDrive, Documents, EDU 790, and I'm going to click OK. Now this worked because and the code that was generated is CD change directory. CD stands for change directory, and then the file path is in quotes. So that whole command tells Stata, I want this to be my working directory. So I'm going to copy that and paste it into my quiz, because the first question is paste or type the line of code that Stata generates when you change the working directory. And this is the command that it generated, CD plus the file path. And it might be different for you. That's fine if yours is not exactly the same as this, but you just want to always know what your working directory is. Okay, so we just did question 1. Question 2. Now we're going to import information about when each US state started and ended its COVID lockdown in 2020. So we're going to choose File from the drop-down menu of Stata. We're going to import our data as an Excel spreadsheet, because the lockdown data are not Stata data. They are Excel data. I got them from, where did I get them? I think I got them from the COVID racial data tracker. So we have data about when all of the states started and ended their 2020 lockdown legislation. Okay, so we're going to import it as an Excel spreadsheet. In the dialog box, we'll click Browse. We'll navigate to our working directory. We will import the first row as variable names, and we will make the variable case lower, which means all of the names of the variables will be lowercase. That will make it easier to type the names. Then we'll click OK. So we go File, Import. So File menu, Import, Excel spreadsheet. That brings up this dialog box. We click to Browse. We browse to our working directory where we've saved the lockdown data. Lockdown 2020. We click Open. Now, we can actually see a preview of our data, and that's great. I'm going to scroll down to make sure there are no extra rows and no extra columns that are accidentally showing up, because sometimes when you're importing Excel data, Stata thinks that missings are actual data. But in this case, it looks clean. I've got 50 rows and I've got 5 columns. Oh yeah, A through E. Okay, so this looks good. I'm going to click to import my first row as variable names, which means that state, governor, start, end, and name are not data. They're variable names. They're the names of the columns. So by clicking this, I tell Stata those should be what you call the variables. Those are their names. And I'm going to, instead of preserving the variable case, I'm going to click lower. But in this case, they're already all lowercase, so it doesn't really matter. But I'm always in the habit of clicking lowercase variable names because it makes them so much easier to type. Okay, so we click OK. And voila, under variables, we now have 5 variables: state, governor, start, end, and name. I'm assuming there are 50 rows and 5 variables, just like we saw in the preview. If I'm not sure, I can click describe. And sure enough, there are 50 observations, 50 states, and 5 variables. And we see the variables right here. Okay. So we did that task. Now go back to our quiz. Our plan is to merge this lockdown data with the COVID-19 data, the COVID deaths data. And the variable on which we're going to merge is the variable state. Okay, that means that when I see, let me browse these data and show you what I mean. It means that when the other data set sees Alabama, it pulls in all of this information about Alabama. Every time it has an Alabama, it's going to add this information, columns about this information. It means every time the other data set has Alaska, it's going to pull in these variables. Every time it has an Arizona, it's going to pull in these variables or this information. Okay. So in order to make that possible, we have to make sure that state is named the same thing in both data sets, in the COVID deaths data and the lockdown data. It has to have the same name. In this case, it does. It's lowercase state in both data sets. But there's one problem. In the other data set, in the COVID deaths data set, states are first letter capital and the rest of the letters are lowercase. Here, they're all caps. So that's a problem. We're going to have to fix that or else it won't merge, because Stata doesn't understand if a character isn't identical, including spaces, capitalizations, etc., it won't merge. It won't be treated as the same. So it has to be identical. The name of the variable must be identical, and the spelling and arrangement of the variable names must be identical. So let's see what we are tasked with doing next. We have to get this into what Stata calls proper case, or you might think of it as title case, instead of all caps. Right now it's in all caps or capitals. So to do that, I'm going to show you, there are different ways to do this. I'm going to show you kind of one of the longer ways to do it, which is that we're going to choose data from the drop-down menu. We're going to change the data, create or change data, and change contents of variable. Then we're going to choose the variable state from the drop-down menu. We're going to create a formula for how to change it. We're going to use a string function called string proper, str proper parentheses. We're going to put the variable state in the parentheses, and then we're going to click OK. Okay, so that goes under data because we're changing the data. We're going to create or change data. No, we're not creating a new variable. We're changing the contents of the variable, which means we're replacing the variable in essence. Creating a new variable is to generate. To change the contents of a variable is to replace it. Okay, we are choosing the variable state. The new contents we're going to create. We're going to go to function. We're going to choose string because it's a text variable. We want the function string proper. It can be a little hard to scroll down and find these because they're not perfectly alphabetized. There's string proper. Okay, string proper, click that. Oh, I have to double click it. Okay, once it's there, instead of this S in parentheses, we actually have to type the word state. Then we click OK. And I'm saying that I want to replace the old values of state with a proper noun version of state. That's what I'm telling it. I want to take the old version of state and replace it with a proper noun version of state, which means capital, first letter capital, rest lowercase. And I'm going to click submit. And it says it worked. It says replace state equals string proper parentheses state. And it says that 50 changes were made and there are only 50 observations. So let's browse the data and see what happened. And sure enough, all of these are now properly written in title case or proper case instead of all capitals. So it worked. Okay, let's go back to the quiz. It says paste or type here the line of code that we ran, and that line of code was replace state equals, there's just one equals, string proper parentheses state. Why is there one equals instead of two? Because we're telling Stata to create a new rule. We're not testing whether something is true. We're telling Stata to make something true. And by defining state as the proper noun version of what used to be state, we're declaring an equivalency that wasn't there before. That's why it's one equal sign instead of two. And we'll return to that concept in class. Okay, so then we browse the data and we see that it worked. And what did we accomplish by applying the string proper function? The answer is we made the all caps version of state into title case with first letter capitalized and the rest lowercase. I should say the first letter of each word capitalized and the rest lowercase. Okay. It was previously in title. It was previously all caps. It was previously all capital letters. Okay. Now, using the file menu dropdown, we're going to save this. We're not going to save it as an Excel sheet. We're going to save it as a Stata data file, a DTA file. So that way we'll be able to do the merge. Okay, that's important because we need the lockdown data to enter into the COVID deaths data so we can analyze them together. Okay, so we're going to go back to the data and we are going to go File, Save As, and we're going to call this lockdown 2020.dta. Oh, I think I already have it here because I've been practicing, but you will not have it yet. So we're going to call it lockdown 2020.dta. You can type that here, lockdown 2020.dta. Or you don't have to put the .dta. It will know because it knows that you're saving a Stata file. Okay, so save. And it will say, for me, it's saying, do you want to replace it? Yes, because I already saved it once. So that worked. And I know it worked because it says save and then it says it was saved. And there are no red error messages. Okay. Our next step is to open the original data set, the one we used last week, which is the COVID deaths data. And so we're going to go back to Stata. We've already saved lockdown. We're going to come back to it later, but now we need to open the COVID deaths data because that's going to be our main data set. That's the real data set where we're doing our work. Okay, so we go File, Open, CDC COVID deaths. That's still in our working directory, Documents, EDU 790. It's in our working directory. We just open it. Okay, now it worked because we have all of our variables here. Now we're going to prepare to do the merge. So to do the merge, here is how you do it. Choose data from the top menu. Navigate to combine data sets, merge two data sets. In the dialog box, choose many to one on key variables. In the key variables, remember we're matching on just one variable, which is state. We want the values of state to be the basis for our merge. For file name of data set on disk, we're going to choose lockdown 2020. and then we're going to click OK. We're not going to click submit. We're just going to click OK because we don't want to accidentally merge twice. If we accidentally merge twice, we're going to mess up the data and we're going to have to start over. So, okay, so merges, you only want to do once. And if you need to do them twice, you kind of have to undo what you did before. Okay, so we're going to go data, combine data sets, data menu, combine data sets, merge two data sets. And there are different kinds of merges, as we'll talk about in class. But we want many to one on key variables. And that means that in our main data set, in the one that is currently open when we do the merge, we can have many versions of state. We do. We have Alabama for white, Alabama for black, Alabama for American Indian, Alabama for Asian, Alabama for Native Hawaiian, Alabama for Hispanic. So we have many versions of state. So the many is the one that is already open, and the one that just has one version of each state is the one is lockdown. That's the one that we're pulling in. So that's why we say many to one. The many is currently open in what we call the main data set. Stata calls it the master data set. And we're going to be merging in what is called the using data set, which is the one that we saved earlier, and that's lockdown. Okay, so key variables. We're matching on state. That's the only one in this case. There could be more than one. And then the file name of the data set on disk is lockdown, DTA. Let me see if I need any options. I don't think so. No. Okay. So we're just going to click OK. Now, here's what we find when we did the merge. Number one, we have new variables that weren't here before. We have governor, start, end, name, and merge. The ones that were pulled from the lockdown data are governor, start, end, and name. Merge is a new variable that tells us how well our merge worked. Stata created that variable. And if Stata creates a variable, it has an underscore at the beginning. Because we didn't tell it to do that necessarily. It does it by default. And so it's called merge, and it has an underscore at the beginning. So what it's telling us in the results window is that 33 records were not matched, and 400 records were matched, were merged successfully. So that's good. We had 433 records. Of those, 400 were successfully merged, 33 were not merged. All 33 that were not merged were from the CDC death data, not from the lockdown data. Nothing from lockdown, nothing from the using data was not used. But 33 from the what's called the master or the main data were not merged. But that's okay. It's probably things that were not in the using data, such as Puerto Rico, maybe District of Columbia. Oh, well, we're getting to that. Okay, so let's go to our questions. According to the results window, how many rows of data were successfully matched? We just saw it was 400. How many rows of data were not successfully matched? 33. Now let's see why some records in the main data did not have matches. In the command window, we're going to type browse if merge double equals 1. Actually, it's underscore merge. Browse if underscore merge double equals 1. So we're just selectively browsing our data. Browse if underscore merge double equals 1. And these are the ones that didn't merge because their value of merge, if you scroll over, is equal to 1, meaning they did not merge. So then we look at who they are. District of Columbia, because it's not considered a state in the lockdown data. New York City, not a state. Puerto Rico is a territory. It's not considered a state in the lockdown data. And United States is not considered a state because it's the whole thing. And there was no national lockdown, as, of course, as we know. Those of us who were in the United States during 2020 would know that there was no national lockdown. Okay. So the question says, which values of state did not have matches in the lockdown data? Those were District of Columbia, New York City, Puerto Rico, and US. Okay, next, let's examine the lockdown file information that we pulled in. We're going to browse the data and scroll to see what are the new variables. Well, we already talked about that. The new variables are governor, start, and name. You could also include merge. We didn't merge in, but merge is just reporting on our success. So if we browse the data, we can report that the new variables are governor, start, end, and name. And again, we could know that just from the variable list, even without browsing the data. Governor, start, and name. Okay. Right. One question you have about the relationship of COVID-19 lockdowns and COVID-19 death rates, we can write any question we want. So there are lots of questions you could come up with. I think a potential question is, did states that locked down earlier have lower death rates? Another question is, did states that locked down longer have lower death rates, etc.? There are lots of questions you could generate. Okay, so now here's the problem. It's not really a problem, but it's something that we need to tackle. We need these data on lockdowns to be usable. And right now, they're strings. So we know that whatever this is, Alabama started, here's what we know. We know that Alabama, as of April 4th of 2020, said we're going to suspend certain public gatherings. They started April 4th and they ended April 30th. So that was pretty short. It's about 26 days. Alaska called theirs shelter in place. Oh, that would be another interesting question. Do the types of lockdowns predict differences in death rates? Alaska started March 28th, they ended April 27th, and so on and so forth. So there are only 50 states. I could do the math in my head and create a new variable that says this one was 26 days. But I don't want to do that. I want Stata to do it for me. So I need to get these strings into something mathematical that I could use. And there is something that Stata has called the date function that will let us do that. So the date function in Stata, I think as in many software programs, kind of arbitrarily uses January 1st, 1960 as a demarcation of dates. So dates are defined either before or number of days or months or weeks or years before or after January 1st, 1960. It's arbitrary. I don't know why they use January 1st, 1960. I'm sure there's a reason, but I just don't know it off the top of my head. So we're going to use the date function and we're going to create new versions. We're not going to replace the strings that are there for start and end. We're going to create new versions and we're going to call it L start and L end. L start and L end for lockdown start, lockdown end. And so we're going to convert them to numeric. But before we can do that, I do notice a little problem with the data. And perhaps, this is something I could have taken care of earlier, but I didn't notice it till I did the merge. And I'll show you what it is. It is that sometimes I just have one space between the date and the year. And other times I have two spaces, like March 28th, 2020, March 31st, 2020. I think I have that in both date variables and I need to fix it because it might mess up the date function. The date function requires the formats to be pretty rigid. So anytime you do any kind of work with strings, converting them to numbers, it's always good to look for anomalies. And that's something that we're going to learn throughout the class. In this case, I just happened to notice that anomaly, and I think we should fix it to be on the safe side. So the way that we fix the anomaly of the extra spaces is with a string function called string itrim, and it means string internal trim. We're trimming internal extra spaces. They also have string trims for extra spaces at the beginning and end, which you can find in the help files. But we're going to use string itrim for internal spaces. And this time we're just going to replace the strings. We're not making new variables yet. We're just replacing the strings that are there. So we're going to replace start equals string itrim start. We could use the dialog box to do this, but we're not going to because it takes too long. And then we're going to replace end equals string itrim end. And so we're just going to run those two functions. And we just did it for start, and it replaced 336 variables. 336 had extra spaces removed. Then we're going to do it for end, and we're going to remove extra spaces from the end variable. And in that case, there were only 8 rows that had this problem of the extra spaces, but now we fixed them. So that's great. We could always browse the data to make sure that they still look normal. And they do. It's just the extra spaces are gone, so that's great. Okay, so we did that. How do you know that the string itrim command worked and the extra spaces in removing them? And it said results window said 336 variables replaced for start and 336 observations, I should say. Also, we see the spaces are gone, the extra spaces are gone when we browse the data. Okay, good. Now we're going to do the cool thing, which is converting those string dates, those words with numbers and year, with days and years. We're going to convert that into numbers. We're going to convert it into numbers. So the code for this is we're going to generate a new variable. It's called lstart. And the function is date parentheses start, well, because that's the variable, and comma, in quotes, MDY, which means that we're telling Stata that I want you to take the variable start and understand that it's written as month, day, year. And thus I want you to convert it. And Stata understands that sequence, and it's going to create these new variables, lstart and lend, that are going to be numeric. Okay, so we're going to run those 2 lines of code, paste them into the command window and run them. Oh, it did not like that. And I'll tell you why. Let me double click this command over here in the command, over here in the history window. It's because the quotes looked curly when I pasted them in. We don't want curly quotes. Curly quotes will mess you up. We want straight quotes. And the default in Stata, if you're typing in Stata, it'll give you straight quotes. But if you're copying and pasting from PowerPoint or Word or whatever, or HTML, it might make them curly, and we need to get rid of the curly quotes. So once I fixed that, it worked. I have a new variable called lstart. It does have 89 missing values for states that weren't merged. That's okay. And I'm going to do the same thing for lend. I'm going to get rid of the curly quotes. And oops, I need double quotes. And I'm going to hit enter. Good. Okay. Now, just to make sure that worked, yeah, 89 missing values generated. Now it tells me to browse the data again. And I'm going to browse the data, and this is what the numbers look like. They look like 22,000 and something. That's because that's how many days there have been between these dates in 2020 and January 1st, 1960. So there have been about 22,000 some odd days. That's why they look like 22,000. But those 22,000s are not very pretty to look at because my brain does not look at 22,035 and automatically think April 30th. Okay, in 2020, it just doesn't, I don't think like that. So I want to format those so that they look like dates, even though Stata recognizes them as numbers. So to do that, I need, okay, so it says when you browse the variables, what do we notice? We notice they look like numbers around 22,000 that represent days since January 1st, 1960. Okay, so that's the answer to what we notice. Now we got to format them. And so here's what we're going to do. It's just one line of code. It's format. We can put both variables in the command. And the format we want is %td. Oh, I don't think we want this period at the end. So I should probably get rid of that. Okay, we want %td. And let's go here. And now let's browse them and see what we notice. And now they're not blue, but they're reformatted numbers. They're not labeled, they're reformatted. So they're formatted with the format day, month, year to show the actual dates. And they line up with what they're supposed to be. I mean, you can compare here to here and see that they line up. Okay, so what do we notice? Now they are formatted as day, month, year. Okay. Create labels for lstart and ln by running the following two commands. And then we're going to make a new variable. Okay, I'm going to close that up. We're going to label them. Oh, it didn't like it again because of the curly quotes. I got to get rid of those curly quotes. Okay, let's pull that up. I don't know why they're formatting curly this time, but it's not good. Okay, that now they're labeled, which you can see over here when you go to your variables list. Now we're going to look at some descriptive statistics. Now we have to make the lockdown length. To make lockdown length, we're going to make a new variable. Generate lock length equals lockdown end minus lockdown start. If they never had a lockdown, what should their length be? It should be 0 because they never had a lockdown. There was no lockdown length. So we're going to make it 0 if the type of lockdown is defined as NA, which are states that didn't have lockdowns. And then we're going to label that variable as lockdown length in days. Okay, we're going to have to, again, get rid of those curly quotes. Straight quotes in. I'll fix that. Okay, that worked. 89 missing values generated. We now have a new variable called locklen, which is the length of the state's lockdown. And we replaced the ones where there was no lockdown, we replaced them as 0. Now we can learn some stuff about the lockdowns. We can learn, for example, the mean length of lockdowns across states. And for that, we need to use our summarize command. So we can summarize locklen. And that tells us the average length of lockdown was about 51.5 days, with a standard deviation of about 49 days. The range was from 0 days to 259 days, but the mean is about 51.5. Okay, so the mean lockdown length across states is 51.5 days. And then here's what I want to do. I want to get the mean lockdown length in days if the state was led by a Democrat or a Republican. Now, we can hypothesize what that might be. In fact, question 15 is going to get to that. But let's see what we get. First of all, how do I know if the state is led by a Democrat or Republican? It's in the governor variable. And so we're going to scroll over here. We're going to say, okay, how do we know? The answer is R is Republican, D is Democrat. If we're not sure, I'll show you a shortcut. We can tab governor. And it tells us there's only two values, D and R. 192 observations are Democrat led, 208 are Republican led. So here's what we want to do. We want to summarize locklen separately for Republicans and Democrats. We can do that in a few different ways. We can do by sort governor, summarize locklen. And I see now that for Democrat-led states, the mean is 77. For Republican-led, the mean is 28. Or I can do it a different way. I can do tab stat. We saw this last week. Yeah, we saw this in topic 1, I think, in the first class. Tab stats, locklen by governor. And it's the same data, 76.6 versus 28.3. Or I can do summarize locklen if governor equals 1. Oh, sorry, I meant to say governor equals R. And then same thing as governor equals D. So, but the upshot is 77 days versus 28 days. And this is going to be 77, 76.6, I think. You can round it to the nearest whole if you want. Yeah, 76.6, 28.3. Is this what you would have predicted? Why or why not? Well, yes, we heard in the media that Republican-led states were more reluctant to impose long lockdowns. So the difference in lockdown length is somewhat expected. You can write anything you want, but that is a reasonable answer. So I see now that my submit button has turned from gray to blue, meaning we did answer all of the questions. So we learned how to merge data. We learned how to do some data cleaning and tidying, cleaning up our strings so that we could do some de-stringing, changing from a string to a date. Then we did some summary statistics overall and disaggregated for lockdown length. And disaggregating that by whether this state governor is a Democrat or Republican. And that is pretty much the end of this topic 2 data task. In topic 3, we will do more with these data. to look at the relationship of lockdown length to COVID death rates, and we will look at that differentially by race and ethnicity as well. So I'm going to submit the data or submit the quiz. And I'm going to stop sharing my screen. Thank you guys very much for watching. I hope this video was helpful, and good luck with the rest of the assignment.